Hello, Mohammed. Good evening. Uh, I'm recording this session to answer the interview section of task 5.7. Unfortunately, I was just checking my laptop to do a recording on the laptop, and I found out that I'm getting error messages message on my laptop, so I can't do it on the laptop. But I'll make do using the video here on my smartphone. So I'll go straight to the first question, which asks that what does CRISP DM methodology for data mining entail? What does the data analysis and what does the data analyst do in each setup? Yeah, CRISP DM methodology is an acronym for cross industry standard procedure for data mining. It is a thorough, structured, and validated procedure for carrying out data mining in across industries and companies. Although literature says there are so many techniques that are available across based on preferences of companies and industries. Some techniques have several combine or separate certain tasks, into several stages. But CRISP DM is tested, is validated, and is a structured procedure for carrying out data mining. It entails 6 parts, essentially, which I will list and explain one after the other. There is business understanding, there is data understanding, there is there's data preparation, then the modeling phase, then the fifth phase, stage, which is evaluation, and then the last and the sixth stage, which is deployment. Business understanding, to explain the stages one by one. Business understanding essentially includes defining the purpose or the business priorities for which we need data mining. So we set these priorities and then ensures that the project that we want to carry out is tailored towards, contributing or impacting this priority. And then during the process of this business understanding, we want to ensure that the project that we want to do, its result is measurable, and then its impact on the project, on the business priorities for which we want to do data mining is quantifiable, depending on the nature of the project and the purpose, of doing it. Then we move on to the next phase or stage, which is data understanding. Data understanding essentially includes or entails gathering data that we want to use for this purpose, and then we treat quality issues in the data after exploring it. We treat quality issues, things like missing value, inconsistencies, and all the rest that has to do with missing. With data quality issues. We also look at data integrity issues that may be in the data, bias and all those things, and then we ensure, that we treat all those issues. And then we also begin from this stage documentation about the data and the project procedure. Things like we record issues like the data source, uh, and then having a thorough understanding of the data itself, and then record also the quality issues, and integrity issues that came with the data. So then we ensure the documentation is exhaustive enough in such a way that we don't miss any step, because at the testing stage, this is going to be handy to be sure that we are certain we didn't miss any step, because that's what CRISP teaches, and all assumptions later on are also going to impact on this. So from there we'll move on to the third phase, which is data preparation. Data preparation and data understanding, to the extent of the data cleaning parts, are interrelated. You can be at the stage of data preparation and also be looking back at data understanding, to the extent that you are cleaning the data and then handling other quality or integrity issues. So then the next aspect, another part of data preparation also involves, we might have a need if the data as it came after cleaning it, and then getting it ready and we are looking at it, we might have a situation of creating data that is not available based on what we want to our purpose with the data. What do I mean by that is, we certainly might, at some point, we might need to create some variables that are non-existent in the data using existing variables, just like we did we do in Python, deriving variables based on the needs of an analysis. So that's also going to be part of data preparation. And then we ensure at this stage that any other documentation that we didn't do at the data understanding stage is firmly recorded and noted here. Then we move on to the next stage, which is modeling, part 4. Modeling, essentially, after we have gotten our data prepared and then we understood it perfectly, modeling is making a choice between a combination of the logic, of the data that we have, and then sorry, maybe I can just go back a little bit. In during data preparation also, we are looking at part of studying the data is also looking at certain characteristics in the data. When we try to do visualization, of the data and see how variables are related, which will point towards, the ones among them that we might need to investigate further. That's also going to be part of, sorry for going back, part of data preparation. So the fourth stage, which is modeling, is talking about how we pick the logic in the data that we want to work on, and then make a choice of an algorithm that we want to use to work on it. This is going to be driven essentially by the nature of the project that we are doing, and then the purpose of the goal of the project, which is driven from the first stage, which is business understanding. So when we make a choice of an algorithm to use and then the logic in the data, that choice or that combination is what we call a model. Algorithm essentially is defined as a set of arithmetic steps, that a system must go through to complete a task. More or less like when we use Excel to do we highlight a series of cells in Excel, and then we select auto sum. Excel automatically has an algorithm, within that task, that tells Excel that this requires that you sum, that it sums the number. So That's what an algorithm is in the simplest form. So once we make a choice of based on the nature of the project and the purpose for which we are doing it, we make a choice of the algorithm to use and then combine it with the logic of the data. We have we have made a model, and then what the analyst then need to do is to go ahead and prepare a testing procedure, a testing method to to run to run this model. And then running the model can be done in a number of tools. It can be done in Excel, it can be done in Tableau, it can be done in Python, and we can also do visualization of it. So when we when this is done, we obtain what is called a prototype, a model prototype. A prototype is a model that is still undergoing is still undergoing development. We're still working on it. That's a prototype. So then when the prototype is obtained, is now taken through a validation, which is the next stage, which is evaluation. Evaluation essentially is measuring the prototype that we have obtained against the business goals for which we are identifying in stage one. Essentially, what is being done here the is to test the accuracy of the data in looking at the logic and the parameters of the model, and seeing how it delivers against how his accuracy measure delivers against the goal of the project, the business principle that we want to impact on. So if it has a high enough rate of accuracy, then it is said to be accepted. So then the testing method that the analyst established, at the previous stage, is also going to be made available to other team of or group of analysts who will also um, validate or evaluate this model independently. So when other analysts validate or evaluate this model, the accuracy of the model independently, if it passes, fantastic, it is good, it is good enough, then it can go into deployment phase. But if it didn't pass, a retesting is usually recommended, at which stage which the data analyst need to do a study of the whole CRISP-DM procedure again and see whether some steps have been missed or overlooked, or some quality issue in the data, and then rerun it again. So if a model is not working at all, or it doesn't pass even retesting, then it is abandoned, and then the thinking around the model again is reconceptualized. So the last phase is the deployment. After the model has been passed, has been evaluated, and is certified based on its accuracy, delivery on the goal, the purpose of the business, it can be implemented. So then it starts to be implemented. When it's implemented, we take measurement. The data analyst takes measurements regularly to be sure that its delivery, based on the parameters and the purpose for which it's designed, does not go within the allowable parameters. If there is a drastic change, the analyst will need to then study and see what are the issues that are involved. You understand? And the analyst may also, based on the need of the company or requirements set up by the company, the analyst will also need to do periodic report on it, and if there are need to variate, the parameters based on the business need, there will be a report that details about the procedure, the purpose of the model, and then the current needs, and then the changes that are required to be made. So that is that about crisp DM. Um, the next question is asking about explain what needs to be done before you forecast time series. In other words, what does time series analysis involve? Before we can do a forecast, with time series analysis, essential. I mean, a time series data essentially is a is a is a kind of data that has time as the independent variable. Is a data type that has time as independent variable, unlike other data structure where we have several variables that we are comparing, or we are comparing one variable to the other, or we are comparing so many variables. In a time series data, it's only time that's independent variable. That it may be univariate, it may be multivariate, but time is independent variable. So that is what a time series data is. So um, there are three elements that we'll look at in a time series data before we can talk about forecasting. The elements, these elements are stationarity, autocorrelation, and seasonality. Stationarity is a concept that is looking at in the time series data whereby statistical attributes of the data remains unchanging over time, especially variance and mean. So it means the variance and the mean of the data set does not change over the period, over the values recorded and the time period of it, as differentiated from. So in this kind of a situation, the data will not show trend, it will not show pattern. As differentiated from a non-stationary time series where we have a trend. A trend means a certain direction. Either the data values are increasing over time or they are decreasing over time. So we have a trend. Though that one may also not have a pattern. But a stationary data is the one that doesn't have both pattern and trend. So before we can make a forecast, we need to be sure, we need to ascertain whether the time series is a stationary data or a non-stationary data time series. The second element that we also need to consider is called autocorrelation. Autocorrelation is a phenomenon where a data value in the series keeps occurring at periodic time. That one is an example can be seen in household electricity usage, whereby people go out in the morning, they go to work, children go to school, and the house, is left, so no unit is being used. The data value is at the lowest. People come back during the day, towards the evening and everything, then usage begins to grow until it gets to a point, the peak, maybe around the time that after people have eaten and then they want to go to sleep and then they are putting out some light or some point of usage, it gets to the peak there. And then, it start going down. They wake up in the morning, they go to work again. And then, so the peak is at the highest point at night when all equipment, all points of electricity are engaged. You get to the peak at that point and then start dropping, and then until you get there the following day again. So, this periodic changes in value at intervals is what is called autocorrelation. So we also need to know, does the time series data has that feature or not? The third element that we need to look at before doing a forecasting for a time series data is seasonality. Seasonality is a phenomenon whereby we have fluctuations in data occurring at periodic time. An example can be seen in some sales data, whereby, especially of products that are seasonal, there are some products that around Christmas time they are in season and their sales peak. By the time it's getting to January or after the Christmas festivity, the sales begin to drop again. And then the sales, does not come back to that high value again until next